Rain feels simple because on Earth it follows a stable, repeating cycle driven by the water cycle, where solar energy evaporates water from oceans and land, moist air rises, cools, condenses into clouds, and then falls back down as precipitation. And that entire system works because of a very narrow range of atmospheric conditions involving pressure, temperature, and chemical composition. But rain itself is not defined by water, it is defined by what a planet's atmosphere allows to condense and fall. And that's why on planets like Neptune and Uranus, scientists believe precipitation can take the form of solid carbon, specifically diamonds. And this isn't just a random idea, but a process grounded in physics, because those planets contain large amounts of methane, a molecule made of carbon and hydrogen. And as you go deeper into their atmospheres, pressure rises to millions of times higher than Earth's surface pressure, while temperatures also increase. And under those conditions, methane molecules become unstable and break apart, releasing carbon atoms. And those carbon atoms are forced into extremely close proximity, eventually rearranging into a crystalline lattice through a process related to crystallization, forming solid diamond structures that then fall under gravity through the dense atmosphere, potentially building layers of diamond deep within the planet. Now imagine Earth begins to shift toward conditions where even a small part of this process becomes possible. Not identical to Neptune, but enough to change how carbon behaves in the atmosphere. And the first change would have to be composition, because Earth's atmosphere is mostly nitrogen and oxygen with only trace amounts of methane. So for diamond-like precipitation to even begin, methane concentrations would need to increase dramatically, possibly through large-scale release from methane hydrates stored under ocean floors, or rapid biological and geological changes. And methane is a powerful greenhouse gas, far more effective at trapping heat than carbon dioxide. So as its concentration rises, the atmosphere begins retaining more thermal energy, increasing global temperatures and intensifying convection, which is the upward movement of warm air that drives cloud formation. As convection becomes stronger, air rises higher into the atmosphere, carrying methane and other gases into regions with lower temperatures but potentially unstable pressure pockets, especially inside large storm systems. And within these intense systems, localized conditions could form where methane begins to break apart, releasing carbon atoms. And while Earth normally cannot generate the pressures needed to form true diamonds in the atmosphere, extreme localized conditions, combined with high-energy reactions, could produce solid carbon particles, not perfect gemstones, but dense crystalline fragments that behave very differently from liquid water droplets. At first, these particles would be microscopic, forming around condensation nuclei just like water droplets do. But unlike water, they would not merge into liquid drops, instead remaining solid and growing slowly as additional carbon attaches to them. And once they reach a certain size, gravity begins to pull them downward, initiating precipitation. And this is where everything begins to feel different. Because instead of soft droplets falling at relatively low speeds, you now have solid particles with higher density and different aerodynamic behavior, meaning their terminal velocity increases depending on size. And even small increases in mass lead to higher kinetic energy when they strike surfaces. The first rain would sound different, sharper, more irregular, like tiny impacts hitting every surface at once. And initially, the effects might seem minor, small abrasions on exposed materials, slight damage to glass. But unlike water, which disperses energy on impact, solid particles transfer that energy directly, and over time, repeated impacts begin wearing down surfaces, creating microfractures in materials that were never designed to handle continuous high-speed contact. And as storm systems continue cycling, some particles grow larger during descent, becoming more capable of causing noticeable damage. But the precipitation itself is only one layer of the problem, because for this process to exist, the entire atmospheric system has already changed. And those changes affect every Earth system connected to it, starting with agriculture, which depends on 4 key factors: water availability, soil structure, temperature stability, and atmospheric composition. And in this scenario, all 4 are disrupted simultaneously. Rain is essential for agriculture not just because it provides water, but because it supports nutrient transport, dissolving minerals in the soil and carrying them into plant root systems. But solid carbon precipitation does not dissolve or contribute to hydration.